Hi guys, we'll be solving the 806 D4. Okay, let's see. This problem A. There is a string s of length 3, okay, consisting of uppercase and lowercase. Check if it is equal to yes, where each letter can be any case, for example, are all allowable. What? Ah, this is so easy, man. So we just take the inputs. LLT, scene, T, while T minus minus. I'm not visible. Okay. String S. Uh, string C in S. If let's say string T equal to 2 low. Okay. So we can just directly check, right? If 2 lower of S equal to S, then we can simply print C out S. Else we just need to print no. I think that's it, but on a better way, like let's test it as well, right? So we'll put in the test. And what is this? No matching function for call to lower. I'm not sure, so let's Google to lower in C++. uh, so okay, we got it right. So this is the function, that is our string name is S, and instead of to upper we move it as to lower. Save. Let's execute it again. What? Execute this again. What? Error expected semicolon. I did not put semicolon. So, okay, we are running out of time. For 5 S's and 5 no's. We'll just paste it. So let's submit this. So begin s dot n, s dot begin, comma, s dot n. Okay, accepted. So let's go to the next problem. In ICPC contest, balloons are distributed as follows. Whenever a team solves a problem, the team gets a balloon. The first team to solve a problem gets an additional balloon. A contest has 26 problems. Okay. You are given the order of solved problems in the contest denoted as a string S, where the ith character indicates the problem has been solved by team. So team will solve the problem twice. Determine the total number of balloons the team received. Note that problems may be solved. I think we should check the input, that is number of test cases, and each test case have the length of the string, and they give the characters. Okay. For each test case, output is a total number of balloons received by the team. So they solved three problems. Problem A: the team receives two balloons. Okay, two. Okay, one, two, three, four. Okay, let's try this one. One, two, three, four. What is this one here? Six. Number of test cases. Three. This one. A. This is two, and three. Right. One, two, three, four, five, six. One, two, three, four, five, six, seven, eight, nine, ten. No. Oh, three, four, five, six, seven. Okay, so they are asking like if a solution is there, that's two, right? One, two, four, five. That is total number of characters plus one always. So four, five, six. Correct. So one, two, three, four, five. One, two, three, four, five, six, seven, eight, nine, 10. How many are repeated? 11, 12. No. Let's see. It's Codeforces, right? So let's what is this? Okay. Uh, C is one. C is one. O is one. D is one. E is one. F is one. Okay. O is two times. 4 R C E and S. So you have to add like 1, 2, 3, 4, 5, 6, 7. 7 plus 7, that is 14. Each one we have to count twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh, Wait, what just happened? Like, so the alphabet solved, definitely it's like two times at least we have to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 are there. Then how many had duplicates? That we have to add one. So 15, 16, 17. That's it. Okay. Same. We have the test cases. So what do they give? They give the length of the string first. So we take the string, then we also take the string here. So for before that, we need to know the map, right? We have to store the count of each string. So what we do is map, that is a string, right? So we'll take a character and we'll take the count. All right. So now we have to put this string in the map. So what we do is int I equal to 0, I less than n I plus plus. Okay, ma of s of I plus plus. That's it. So if we do ma dot size, it gives the total number of unique keys. So that is like into 2. So let's say the result will be the total count. That is ma of result, ma of ma dot size into 2. Now we'll take the auto function. So whenever a number comes more than 1, if I dot, then we'll simply increment the res value. So if I dot second is greater than 1, so we do res plus plus. I think that's it. Should be fine, but let's see. Copy, paste, save, command B. Oh wow, I messed up somewhere. So let's see. We have to see this, right? Is it ma of number of keys, right? That is ma dot size. Is it correct or not? One, one, three. Okay, save. 23. What? So res is 2, right? That is two elements. Plus one, that is 3. That is correct. One, two. No, no, no. One, two, three, four. Uh, Five, right? Okay. Why it's 2? So I made out size is not 1. Uh, the thing is, I did not take the input for string. So I think now it should work. Right. So we'll close this and paste this. It should be 5, 2, 6, 5, 8, 17. 5, 2, 6, 7, 8, 17. So this got wrong, right? So it should be 4, 5. That's all. Okay. So what's the wrong thing? 1, 2, 3, 4, 5, 6, 7. Okay, you have to count the each problem as extra one. So 1, 2, 3, 4, and each of the A's as extra one. Okay, so yeah, I'm just figuring out from the solution. Okay, so if it is greater than one, result plus equal to I dot second minus one. Why this minus one? We have already did it. So it's like if it is 4, it will show 4. 4 minus 1, 3. We just add 3. 1, 2, 3, 4, 5, 6, 7. Okay. I guess it should work. 5, 2, 6, 7, 8, 17. So I think that's it. Hmm. Let's try to submit the code. Okay. Hopefully this should also pass. We are taking too much time. Awesome. Now let's go to the third number. Luca has a cipher made up of a sequence of n wheels, each with digit AI written on it. On the ith wheel, he made BI moves. Each move is okay. The Luca is having a cipher, a sequence of n wheels. So let's assume these are the wheels here with a digit AI written on it. These are all the digits. On the ith wheel, he made BI moves. Okay, he made BI moves on ith wheel. Each move is one of two types. Up move, it increases the ith digit by one. If you are okay, after applying the up move on 9, it becomes 0. Okay. Down move, it decreases the digit by 1. That is 9, it becomes 8. And after 0, it becomes the biggest number. Okay. Luca knows the final sequence of wheels and the moves for each wheel. Help him find the original sequence. And okay, so basically, we have to simulate that. So they have given the final sequence. Suppose let's say 9999, they might have give something like 8 7 something. Then we have to see, let's figure out. I don't know. I guess that should be the case. The number of test cases is there, and first line of each test case contains a single integer and the number of wheels. So this is the test case. The first line of each test case contains a single integer and the number of wheels it's there. Oh, okay, that is just 100. Second line contains AI, the digit shown on the ith wheel after. Okay, so 3 is there, then 9 3 1. Okay, after all moves have performed, then n lines follow. N means this one, right? 3 lines follow. So first gives test cases, then number of lines, then give 931, then 3 lines follow. The ith of which contain the integer bi. Okay, the number of moves. So this is the number of moves, and bi character that are either u or d. The number of moves performed on the ith wheel and the moves performed. U and d represent an up move and a down move respectively. For each test case, output and space separated digits. Okay, so it's very simple. So it tells the first move, that is how did we get 9, how did we get 3, like that. So this is the final one. So we have to actually reverse it. So let's say let's figure out first before moving to a solution to check our understanding is correct or not. So this is the solution. This one. So it's telling like so 9 came after 3 downs. So we should reverse it. It will be 8 7 6. Okay, 6 should be the first one. Up down up up. So we will reverse it. What is that? So we should start from the back. Okay. So they up. It was down, right? It was down. Uh, so let's say okay. So if it is down, okay, let's say what is it? Up. So if it is up, it increments, down means decrements. So we have to write it. Up means increment, down means decrement. This is quite intuitive. Okay. Down, down, down. You just keep on incrementing. 0 1 2 3, right? So 0 1 2 3 1 2 3. Okay. So what I told was wrong. Since it's there, that is 3, and up, up. So you do down, down. 2 1, this is 2, and this is 1, and this is 2, and this is 1, and down up. So down means decrement 0. So this is same. So irrespective of this, it should be 3 1 1 should be the answer, but let's see. No, it's 2 1 1. Let me figure out what went wrong. So 0 1 2, yeah, correct. 0 1 2. So since we messed up, let's take one more case. I don't think we need it, but I think since we have figured out, we can just see it. Okay, now let's start. We'll just comment this out. We don't have to forget it. So this is the one that we are going to try out. Okay. Oh, sorry, it's not hash. It's backslash. So they will give you the number of test cases, then they'll give you the length. Until this, it's proper, right? Uh, okay, now they'll give you a vector. So let's say final. So we'll just scrape this. each test case should be entered with a new line. Then we'll say vector int and final. So we make a temporary, we don't need a temporary one. We'll just declare everything as 0 first. Then for I equal to 0, I less than n, I plus plus. Sorry, I don't have to take b, c in v of I. So I just stored 931. Now I have to take the moose. So by taking input itself, we'll directly take it. We have to store the string and reverse it and just store the final result. We are not storing anywhere. So what we do is, in this case, mm, okay. So I have three integers, right? Lel I equal to 0, I less than n, I plus plus. Now the first one will be a number. So we need a temporary number, that is b. Let's say moose. Okay. Now we'll see in for the moose. Now then there is a string, right? String is what do we call it? Uh, Rotations, let's say, like direction, right? So let's say it's the direction upwards or downwards, like that. So cin for direction. Okay. Now we got the moves. How many moves are there? We got the direction. So we'll reverse it. So that is for lli j equal to moves minus, we'll start from the right. J is greater than or equal to 0, and j is minus minus. So okay, now I'm starting from minus minus. Whenever I do a increment, I should do addition. Whenever I do a d, it's a decrement. It's this. U means increment, d means decrement, but I should do the opposite, right? Up means increment. Yeah. So in this case, since we are starting from right, we should do the exact opposite. So if we do like that, okay, so let's start. So if without considering any corner cases, let's just try to blindly code it. If direction of j equal to two things, one is d can happen, or else uh, u can happen. Now if it is d, instead of decrementing, I should increment the number, correct? So what do we do is, uh, okay, so what do we do is, the number, right? What is the number we got? The first number, that is v of I plus plus, that's all. Okay, we'll think about it later, but first let's write the pseudocode. How to handle modulo, we'll just think about it. So if it is upper, we'll decrement it. Okay. So v of I will automatically take care of it. Now our solution is, we have to print all the numbers, right? So for that, lli equal to 0, I less than n, and I plus plus. All right. Now we just have to print c of v of I, because we are already changing that. Now the next challenge is, instead of after 9, when we increment it, it should be 0. So I'm not doing any modulus or something. If it is if we increment it and it becomes a 10, we make it as 0. That's it. So what I do is, if v of I equal to 10, v of I is equal to 0. Simple, right? And if v of I is equal to uh, minus 1, then what we do is, v of I equal to 9, because if it's 0, it becomes 9. So that's it, right? I took all the numbers, each number I'm taking it here. So right, what is, okay, I did not notice it. So let's copy this and paste it. What is happening? uh, All right. So if we do int, it should be long, long, or else again. What is the issue? Invalid types long, long, int for array subscript. What? Oh, all is this one should be int? Is it for that telling? I'm not sure. Okay, let's see. Oh my god, what is this? So, okay, this is invalid types long, long, int for array subscript. What is it trying to say? V is long, long. So, okay, let's just make it in. Let's see what is happening. Uh, Arey yaar, what is wrong with you? Okay, let's. I'm not sure like why it's wrong, but we'll figure it out later. Now it's a contest we can't risk. Okay, what's wrong, man? Int of int. Damn, I have no clue. J equal to most minus one. If direction of J is equal to E, that's a character, and if V of I is equal to 10, yeah, what's wrong? V of I can't be 10 or what? Okay, let's do one thing. Let's just comment this out and try. This is the problem, right? I don't know what is the problem, but let's say, is it running something? Invalid types int of int for array subscript. I have no clue. Invalid types int int. I don't know. I'm just trying some trial and errors. Let's see whether our thing works or not. I mean, I don't know that's the issue, but okay. What does this guy want? Isn't your face defined or what? Nothing like that, I think. I think it's taking some space or something like that. Let's see. I'm not sure, but let's not take any computation here. Let's try to debug it. Like, what is the problem? We have to see that direction of J. What? Absolutely no idea, man. What is this? Oh, thank God. Okay, direction is a string, right? What did I take? I took int. Understood. Man, this is so silly. String direction. That's okay. So we got a good learning here. So let's say we just ignore all this thing. We wasted too much time, but yeah. So this is how we debug. That's okay. 21190. I don't think 90 is a answer. Oh, 04969. Perfect. That's it, right? I think you just need to put space, control A, control C. Oh, it's already 2.5 hours, I think. I think 2 hours, not 12 minutes. So what is this? It's taking too much time, so I don't know. My internet is gone. No, internet is perfect. I think Codeforces. What's happened to Codeforces? I'm not able to check my virtual contest. Uh, this is so hard, man. What is this? Yeah, just come on. Came back. Right now, I'll paste what? So I'll just paste this. Yeah, I think that's it. But submitting this, it should actually give a submitted accepted option. But let's see. Perfect. Now let's go to the next one. That is D. You're given n strings of length at most 8. For each string is determined if there exist two strings such that Si equal to Sj plus Sk. That is, Si is the concatenation of Sj and Sk. Note that J can be equal to K. Recall that concatenation of strings is where P and Q are the lengths of strings S and T. For example, concatenation of code. Okay. So they will give a series of strings of length at most 8. There can be 8 strings. That's what they mean. For each string, for each of the string, determine if there exist two strings Sj and Sk. Oh, okay. That is Sj is the concatenation. Okay. We just have to see whether yes or no. Okay. It's there or not. The first line, okay, number, the how many strings are there, n lines follow, of length of at most 8, consisting of lowercase English letters among the given n strings. There may be equal duplicates also. That's okay. Sum of n over all test cases. That's okay. Okay. For each test case, output a binary string of length n. The ith bit should be 1. Okay. So we have 10 power 5. And they gave like the sum of n over all test cases is 10 power 5. So if you do 10 power 5 into 10 power 5, obviously we'll get time limit exceeded. So um, each string test case output a binary string of length n. Ith bit should be 1. If there exist two strings sj and sk, okay. Oh yeah, yeah, fine. That's fine. So ab does it exist? How? Oh, this can be same. So this is ab. Okay. And AB doesn't exist. ABC no. ABACB. AB ABC no. Okay, how come third can come? Okay. What is this one? S2 is not the concatenation of any string in the list. Oh, okay. ABC is there. This C, A, B, and C. Okay, X. Yeah, true, true, X, X, and X. True. No, this is not a concatenation. Yeah. Code force. No. Huh? Why? Why the first one is code fork? Okay. So basically, we have to find the strings that are concatenated. If they concatenate, they should form a common string. So let's see how can we do this. Uh, okay, I'm just thinking out like one method that we know is brute force. Just take all the combinations like this and this, this and this and this like this. But the thing is, it is 10 power 5. So 10 power 5 into 10 power 5, at least 10 square. 10 power 10, then 10 power 4 test case is also there. No, no, no. Sum of n over all test cases is 10 power 5, right? So they can give you 10 power 4 test cases, and there can be sum is 10 power 5 ends, right? Number of strings will be 10 power 5 and 10 power 4. So even if we take, it will be like 10 power 5 into 10 power 5 cases. Yeah, it will be too huge. So how can we optimize it? You just have to know whether hmm, you how do you match it. So there is an algorithm, I know, but should we use it? Okay, first let's sort it because 10 power 5 seems something like a login approach and login. So we just sort it. After sorting it, exactly right. After sorting it, you check whether that number is there. You come from the last and you check whether the first number is there and what is the balance number that is there or not. If it is there, then it's a possibility. Then what we do is we go down. uh, okay, we go one step down. So two strings should form this number. At what method you should split this? Does this exist or not? So it should be something like so you sort it, you get the prefix values. So let's say you put everything in a map. Then if you do AB, does you say that does AB exist? If AB exists, then check in the map that does ACB exist or not. If ACB exists, perfect. That's it. So if it's there, then you don't have to worry about it at all. Next thing is ABC. Just check A exist, then check whether BC exist or not. So you have to do like that substring you have to do. So how do you do that in C++? That's the thing. In Python, you just have to do S colon this. So just think of the time complexity. Okay, you append the string. You kind of you should know that, right? So from this to this, s dot substring of this, s dot substring of this, does this exist? You are creating each string, right? Yeah, I think that's it. So I think that's the only way also, right? You first you have to put every string in a map, and each string you have to iterate it. So if it's of length 1, definitely it's no. If it's more than length 1, then in that cycle you put that string in a for loop, and that for loop should put breaks in each of the things, and then that substring should be there or not. So this is that if it's not there, then go there until it goes to the n minus 1th point. It will start from first point and it goes to the n minus 1th point. So it, yeah, I think that's the only reason that That's the only thing that we can do, but let's try. Yeah. So, what is the input? We have n t test cases and number of strings, right? Okay. Okay. Now, what we have to do is we have all the test cases. Now we have to take the n value, and from n value, each of the n value should contain a string. Yes, then each of the string should be mapped to no, just the set. It's not map. It's not it's a set. Whether the string exists or not. That's what they told. Duplicate can exist, but set performs the search also faster. Yeah, you just have to check. So it will be like log and search. Yeah, I'm a yeah. So what is it? It stores the string. Then what you have to do is uh, I have to iterate through the strings. Okay, so n. Yes. So here also I again forgot I have to take the n and cin s sc dot insert. So first time we don't have to think about anything. We just insert whatever comes in. Then on the second time you have to iterate through it. So you have to also store it because we have to convert it into binary, right? So how do we store it? We simply store like vector uh, string. Uh, you just say like strings or something. Yeah, vector string vector. I think that's enough. So this vector holds the all the strings, right? So vec dot push back of s. Yeah. So you inserted the strings and you are also pushing back the vec. Now what we can do is we have to iterate through all the strings, right? So now we do, but we'll just print like that. That's it. So let's follow consistency. Zero I less than n I is happening. Plus plus. All right. Uh, sorry. Uh, we'll take one string and do the operations whether that string exists or not. I don't know substring algorithm. Like I have to check for the syntax in Google. So what you have to do is for we'll check for the substring first. Substring algorithm. How to find the substring in a string in C++. I don't think no, this is not the right approach. S dot substr something like that is there. Hmm. Okay, substr. Where is it? Yeah, so this one, right? Dot pos plus one. That is position. You don't have to do position. Position is always zero. So we can just try it like this itself. So let's say if I do substring of one, what will I get? It will ask me to log in. Yeah, exactly. So I don't want to try something like that and waste time here. So zero, one, two, we can just find out, right? Position 0, 1, 2, 3, 4. So substring of 4 gives from here to everything. So 0 to you have to slice it, right? Yeah, something like this. So 0 to pause. 0, 1, 2, 3. So 0 to pause. Pause is 3 here. 0, 1, 2. Okay. So I should do 0, comma 1. Right. First one is 0, comma uh, pause means the exact position, that is 1. So only the single character is taken. Right. Okay. So if it's 0, comma 1, it will give you only the first number. So let's say s dot this one. Okay, we'll take that. Now, before that, starting that, we have to see that if v of I, the string dot size is equal to 1 means we'll simply output 0, and we just go to the next one because we don't care at all if the n comes, then else we have to do all the computations. So how is that possible? So for ll j equal to 1, so from which we have to slice it, j less than, so I should slice from 1. Suppose let's say string is like 3 digits a b c, I should start from b, that's it, and c I don't have to slice at all. So j equal to 1, j less than v of I dot size minus 1, v of I dot size minus 1, and this is j plus plus. So what we do is here 0 comma j, this is b of uh, okay, so we got the first substring here, but it should be j plus 1, that's all I think. So no, I think it's v of j, right? I don't know, but uh, why is it coming like this? Yeah. So this is let's say this one. If sc dot count of it, and you can repeat the same value also, right? That's what they told. Sc dot count of this, and sc dot count of v of we'll just do some trail runs and just check, that's all. J yeah, so if it is there, then C out 1, take. It comes out of this loop. So okay, we can do one more thing, that is ll flag equal to 0, and let's say here flag equals 1 break, see out flag, whatever be it, it will directly say. So this is the else condition, right? Okay, this is if this is okay, if is there, if it is not there, it just continues for okay flag, okay, right. um Pause means it's just a number, and that number plus 1 it takes, and 0 to n minus 1, I think it's basically it. So let's say go to the Codeforces problem, and I'm like confirm, but I'm not sure. How to see. Let's wait for a new error. Yes, that's correct. V is not declared in scope. Let's keep it V. I don't know why I'm changing it. Let's wait for new error. Come on. Yeah, that's it. Comparison of integer expression of different sightedness. My God. Um. mm, no, why is it showing this much errors? Oh my God. I did not cause the count. I think. Okay, so we got something right. 1 0 0 1 1 1 0 1 0 1 0 0. Okay, so we have got something. It's not taking C and ODE. What is it? COD and E, right? Okay, so I think we are almost there. So 1 0 0 0 0. So it is the second one gone wrong. So 1 2 3 ABC, right? AB is already there, and C is also there, but it did not take it. 0 1 2. Then only it will take. See, size is 3, so it will go to 2. It should take. So I think this value, right? Perfect. Yeah, so what I did here is 0 1 2, right? It takes 2 here. 0 1 only it will take. If we do 2, everything, it will include that 2 value. That's what the substring does. That is 0 1 2. It takes the position that is 2, that is 0 1. That's all. If we put substring of 2, 2 is inclusive and gone. 0 1 1 1 0 1 1 Right? Okay, copy. I'm trying to submit the code. Let's see what is the result here. It seems good. Okay, now let's go to the next problem. Okay, now 5,000 people have done. Let's see our standings. Is it possible? I'm losing my energy here. Nice. Uh, Doing great. Let's see what is this. Oh, wow. It seems like Sudoku or crossword. You are given a square grid with n rows and n columns. Each cell contains either 0 or 1. In an operation, you can select a cell of the grid and flip it from 0 to 1 or 1 to 0. Find the minimum number of operations you need to obtain. Uh, so he just rotated to 90-degree and again rotated, then again rotated. Why did he rotate like that? Find the minimum number of operations you need to obtain a square. What? Can select a cell of the grid and flip it. For in an operation, you can select a cell of the grid and flip it. Find the minimum number of operations you need to obtain a square that remains the same when rotated 90 to 70. Yeah, what is this? Okay, the first line of each test case contains a single integer t, the size of the grid. The number written in each cell. For each test case, output a single integer. The minimum number of operations needed to make the square look the same rotated. I have no clue, absolutely no clue. In the first case, we can perform one operation to make the grid 0 1 0 1 1 0. Okay, now all the rotations of the square are the same. Oh, okay. In the second test case, all rotations of the square are already the same, so we don't need any flips. I mean, uh, how? That is 0. Okay, okay. Yeah, so this is 0 and that is done. Okay, so we need to know the minimum number of flips so that whatever shape you rotate, uh, Okay, whatever shape you rotate, it remains the same. Either you can do 1 to 0 or 0 to 1. Both ways are possible. Okay, now so let's see for the fifth one, this one. So here, what happens? Oh my god, sorry, I'm not visible. Yeah, perfect. I'll keep my face here and I'll zoom it a bit. It's not visible for me. Yeah, and I'll put it back here. Triple one double zero double one zero double one. Okay, okay. If I add it, how should I say that? All numbers means all corners should be same. All length also should be same. All the vertices like that, right? So they are telling that. Mm, okay, either. So what about we can take this one, this three ones, and just put it here and just see the difference. Okay. Now we see the difference here, and then again come here, then again come here, and then again come. So we take one. If we want to take the first one, first row, what should be the minimum number of changes, right? So that is the one thing that we can find out. Similarly, we can go inside. We do all the things. Middle one, you don't have to worry at all, right? We don't have to worry at all. But challenges, yeah, it's like you have to change that. So that's it. I think that's it. It's more of an implementation, right? There are 100 test cases, are 100, and yes, 100 you can do whatever you want. So how much diff that is happening for one number? Take the second column, pass it. One, two, three, four. What is that? So for each row, right? For each of the edges, you need to pass and ask what is the row value? What is the diff? What is the minimum cost to build the outer line? What is the minimum cost to build the inner line? Then go inside again. Then go inside again. So you have to know one, you pass it. Second, also you pass it. Third, also you pass it, and fourth also you pass it. So if we do like that, we know the, I think we can minimize the cost. That's it. I think 0 1 0 here, you put 0 1 0 here, 1 will be the cost. 0 1 0 here, 0 1 0 here, 0 0, this cost will be different. I think that's it. But how do we code this? Okay, so first thing is we take all this one. Then one thing that we need to be clear is it's a square, so start point and end point will be the same. So there are four chances: left and right you should pass, this you should pass, this you should pass, and this you should pass. So how do we do this is there is a outer for loop. Outer for loop just tracks the these two indexes, the edges, the edge numbers. Then it goes this one, that is first it tracks the outer edges, then it goes to inside. The outer for loop is responsible for inside, then it goes one week straight. So it can be an even number and it can be odd number, 1 2 3. So it's like 6 or can come, and 5 also can come. If it is a single number, let's say it's 5. Okay, so 1 2, uh, there is only a single number. Let's say 7, 1 2 3 6, that is 7. That, so only single point will be there. But if that is the case, then so outer a for loop is responsible for maintaining the uh, numbers, right? From the corner it will start 0 and n minus 1, 1 and n minus 2. So it takes it. So we get the indices. So now everything is simple. We just have to iterate the indices. That is, We got this right. This is a this is a column number, and this is also column number. Row is 0. Now next one, this becomes the row, and second one becomes the column. So this one, right? You can iterate it actually. So got this, but this is the one. The 0 to 1 is the one. You have to iterate 1, 2, 3. So outer for loop, it's clear. Like we'll take the corners like this, and after getting the indices, there is an inner for loop which has the count of 4, 1, 2, 3, and 4. Okay, 1, 2, 3, 4. Now the outer for loop gets it. And second one, position change. Position change means what? It goes to the next number, that is second one. It goes to the second iteration. So second iteration, 1, 2, 3, 4. So there is a second one and there is a third one. Third one will have the edge tracking. So first one is the number tracking. Second one is the position tracking. So second one is the um, first one is the numbers corner tracking, and second one is the which edge you have to check. Fourth is the direction, like with which edge you have to pick is the second. And third, okay, then the third for loop is for rotating it. You simply rotate it and check it. I don't have a popular method to do it, so let's directly code it. Let's see what happens. So for this, we'll create a 2D vector. I think I need it. Yeah, fine. So we already have a 10. Okay, so we have to clear this. All right. Now we just have to put LL here. It's a square, right? So now vector. I just bring you. I can't do that. Yeah, no issues. Vector LL B of I'm not sure. So I think you have to again take an input, and that's enough. I think it will automatically declare an empty vector. So declare 2D vector in C++. So I think this is what we want. So we have already, like, we declared the vector now. Now what we have to do is for LL. Uh, Remember that it's not a number, we are coming it as a string. Okay. So it won't take it as a number, I think. What does it give? Does it give us a number? Yeah, it will take as 10. So you just take it as a string. See, if we take this as a number, right, it will take as a 10. So you have to take it as a string and then convert it and then put it back. So let's say the outer for loop, string s, cin s. Now for LLJ equal to 0, j less than n, j plus plus. Uh, Now what I have to do is p of I equal to s minus 0. So what is the ASCII value? 65. ASCII value 48. So you just get the difference, right? So let's search for your ASCII value. 48. 65 minus 48 is how much? Convert string, convert character to ASCII. Yeah, so there is nothing wrong, right? Yeah, that's it. It's a number, and this is also a number. See, it's a character, right? That's it. So you are just putting that. So what you do? You have 5 J. Simple. Over, right? So we took the string. Each thing we are just putting it. So this is done. First thing, as I told, it will be 0 and n minus 1. So it will be till n by 2. So suppose the number is 5. 5 by 2 is 2. 0 less than 2. So 0 and 4, 1. That's it. And 3. Correct? 1 and 3. So let's say if it is 3, 3 by 2 is 1. Okay. 0 only will be taken. 0 and n minus 1. So I think it's just n by 2. That's it. So, okay. So for 0, I less than n by 2, I plus plus. Okay. Now, it's so tiring. So for simplicity, let's rename the variables. So let's call, let's bring two, that is start, and the end. Okay. Okay. Now what should I do is start is equal to v of no, start is I, and end is what, the last number, that is minus I minus 1. Correct. So 5 minus 1 is 4, 4 minus 0. So next one is 5 minus 1 is 4, 4 minus 1, that is 3. So 4 will be there, 3 is there. So start and end you got now. So what is the next problem that that I told? So once you get this, you have to just twist it. You have to check it. Check it comes on the fourth line. Uh, you have to know which one, upper or lower, upper or side or lower, which one. So we'll do it on the go. So upper, side, lower. So which direction you need to take. So for that, let's write it down so that it will be easier for us. Okay. So now it will be what on the first step. If it is here, what is it? It is the I value, right? Correct. So it is I or j. It doesn't matter because it's a square. That is I. Now what is this one? This is start. That is the column number because I'm starting from the top. Now end, it is also high value, it is end. Okay. Now if we twist it, what happens? So if we twist it, I value remains the same, but j value is different. So I value is there. Start, no, now it becomes the end. So what is that edge called as? That edge is called as n minus 1. I is there, n minus I minus 1. That is, so you call it end. So you're taking this one, this one. This means it takes that square only, right? That's it. So start, end. Then I plus 1 means it goes to I. So you wrote right, I. So this one is nothing but start, end. If it's on the left, what is it called? It is start, end, and it goes down, that is end. And what is this? This is also end. Okay. Now starting from the left, so this side, what is it called? End, end. And what is on the left side called? That is end and start. End and start. Okay, nice. Now again we start from here, that is end start. Now what is the above one called? That is always start and start. That's it. Okay. Now what we have to do is we got all the conditions. So these are the four things that will come. So you don't what you have to do. How, can we make it simpler? Uh, if I call something, it should automatically tell, right? 1, 2, 3, 4, 3, 4, 1, 2. If 3 means it should always tag end. So M of end, how should I like code this, man? That's the problem. So, okay, let's assume that these are things we will be checking it. Now, each time I should draw a square. How am I doing it? So that's a very interesting problem. So I'm not putting in my original code. So I'm just brainstorming it. For a straight line, what do you do? From start to end, you put one for loop. From end to this, you put one more for loop. For this to this, you put one more for loop. And from this to this, you put one more for loop. That's enough, right? So you put different for loops because it is plus, and the end will be plus plus plus, and third one this plus plus plus, and fourth one this plus plus plus. So what you have to do is this is a for loop, and this condition you pass it to that function. This one you pass it to that function. Third you pass it to that function. Fourth you pass it to that function. It's exactly like that. So what I'll do is okay, so now what we'll do, we have to start like int j. I think I is already there, right? Let's make it something more meaningful, that is traversal, right? So let's say top traversal. So this is top, right, down, left. So we'll call that. Okay, yeah, top is start, then top is less than end. So you just have to start and then go till end, till end, end plus plus. So this is one for loop. Then next one is left. That is left, left. So sorry, right, right, right. We'll change the positions later. So we'll first copy paste these things. After right, it's down. Okay, no problem. It's bottom, but down. Then left, left, left. Okay. Now what happens is top. It starts from start to end. That is very obvious. No, no, no. No, no, no. It's like always it's fixed. Always it's fixed. Okay. So what are the conditions that I can come? You don't have to worry about the comparison operator, but just we'll see what is the number. So that is nothing but v of what? V of what? I don't know. I don't know that. Yeah, it's always start only, right? So it's always the start. Then top is columns are increasing. So you put top. That's it. Not equal to whatever be the number, you just put cost plus plus. Yeah. Start and top 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 will go to the end. That's it. Now right equal to start. So right is start. So what is the one that is it's coming, that is uh, start is incrementing, that is left side is incrementing, that is right, correct? Right, end. Of right not equal to something, then again you have to do cos plus plus. Okay, now comes the third, bottom. It starts from left. What is decrementing here? That is so down starts from end. Down is greater than or equal to start. Down minus minus, right? So down end means what is coming, that is down is decrementing. So down is a column. So what is this one? End, correct? This is end because it's the row. not equal to. Okay, fine. Now we have to again decrement. We have to go from bottom to up. So in order to go from, we start from end. We start same thing, greater than or equal to start left minus minus. So which is decrementing? Row is decrementing, right? So this is left is decrementing, and what is fixed here? Start. Why did top come? Top, right, down, left. Yeah. So left is decrementing, not equal to something that I have to figure out what is that. Uh, so it's if we, so this is the one. We got kind of like got the pseudocode. This is for motion. Okay. So this is like we are just traversing it. Now the challenge is which side of vector I should choose and pass it to this. So that one is very interesting. Uh, okay, we can do like four, one, then I'll put this, two, put this, three, put this, four, put this. But that is like too awkward, I would say. It would work, but let's not do that. Instead, what we can do that is, uh, I'm not sure like how to do this. Do we have time? Perfect. We have 1 hour more. So what we can ideally do is, if it's this to this, what is running? Right is keeping on running, no? So if it's right, call plus plus this. If right pass. So right should be a variable plus call plus plus right, and what is the operand you want to use? Plus. If it is plus, you put plus. Then based on that, you change the values. You tune the values. Right. That's it. So we have to pass the vector. This is a function, right? So what we do is we put inside if domain. So what is the value that it needs to return? It have to return the cost, right? What is the cost? It's a LL. So cost, let's say cost traversal. Now we just have to put it. See, I don't worry about those things. See, you have if you're okay. Now we just need to return the cost because all the traversals, right? Now left thing is that only they will only decide. Okay. Now what we have to pass is vector LLB you passed, right? What is to pass? Start and end, comma start, comma end. Okay. So what was that? Some cost traversal of v, comma start, comma end. Now you passed all these things. Now these three things: start, start, and end, end. So if what can I say? There are like fourth cases, right? Uh, you take the first one. You then pass this. What is the minimum number you're getting? No, it's like you take the first one. You have to pass these four to that four. Okay. This one to that four. This one to that four. This one to that four. So if you pass this one to that four, you will get one value. This value, again you get one value. This one, again you get one value. So which one should be the minimum, right? So if we pass all these four, the minimum of all these four will give those values. So what should we do is Yeah, we have to pass at least 4. So we'll create a variable. We can't do anything. A, let's say it's top cost. So let's say it's top cost, this is right cost, this is bottom cost, and this is left cost. Okay. Now what we have to do is we have to pass the corresponding indexes. So you pass start comma end, start comma end. So maybe you can, let's assume you are extracting it. So what is the one that you're passing? Uh, okay, let's think slow. First one, if this happens, uh, I have to kind of always increment the values, right? I kind of want to, I think this is not needed because start and end you have already passed start, end also, What you have to know is which column should be static and which column should be variable. Okay. So if it's top, what should be this? Right. So if it's top, you increment the column. If it's a right, you decrement end. So you decrement left, you increment, you decrement. So we'll just write down, else we'll forget. If top, uh, increment, what should we increment? Column, something we should increment, right? Yeah. Then if it's right, you should decrement something. What is that? End should be decremented. No, row should be decremented. Too much errors can come. Seriously. Bottom means left should be channel, right should be minus minus. Left means something should be plus plus. This is plus plus and this is static. So let's map it like 0, 1, 2, 3. So let's say I am 0 and this is 1 and this is 2 and bottom is 3. Now what happens is we have to do it based on the further choice, right? We have to do it based on further choice. So 0, if it's 0, it should understand that its column should be plus plus. How does it know that? Plus 1, plus I, uh, plus 1. Oh God. So how about instead of doing this, 1, 1, 1, 1, second, we check the deviations, right? So you can traverse like 1, 2, 3, 4. 1, 1, 1, 1 is there, right? So you take like 1, 0, 1, 0. If both are there, then it's that. Then what you do is you go to the second one, this second one, this second one, this second one, this second one. So what is the minimum value? No, what is the maximum that is happening? It's always like 4 only. It's always only 4 because it's a square. So you go to the second, this second, this second, this second, 0, 0, 1, 1 or 0, 0, 0, 1. What is the maximum value? Then you put 1. What is the minimum value? You take that. If it's 2, 2. If it's 1, 1. That's all. Okay. So what you're telling is does make sense, right? Okay. Now uh, I'm not sure like how to do this. Let me think. I think that is the only solution. Yeah, so it's the second value, then it's the third value here, then third, you go for fourth, 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 fourth. So how will you code that? Okay. increment it. If we increment it, plus 1, end plus 1, j minus 1, minus I, so you put that minus thing. Okay. Let's do that one. Yeah, I think we have to scrap all this, scrape it. So for LL, this is like a very common approach. Let's say, so n by 2 you are coming now. So you take this as uh, start. So start should be the first value. So that is, so I'm just putting left side. Okay, that's all. Whatever be the value, I just put minus that number. So what is it? So you take what is that integer value there. So 4 minus, see, it's like 1 and 0, right? 3 or 4 minus 3, which is smaller? It's like 1 or 4 minus 3. No, no, no. It's 3 or 4 minus 3. Watch is this one. So either you add all ones, add everything, and 4 minus that. Whichever is smaller, you take that. Okay. So cost plus equal to V of cost plus equal to V of something. Cost plus equal to V of something. Cost plus equal to V of something. Okay. Now cost plus equal to V of something. What is it? First one is start. Start gets incremented each time. So that one, what do you want it to be incremented? That is J. No, no. Start is static, right? First one. This is static. And what is this one? That is end value, right? So this is incrementing. Yeah. On the right side, something is decrementing. If it's addition, it should do minus J. Okay. So what is static here? You put all the static first. That is end is static here. On the bottom, what is static? End. End is what? Uh, it's a row. So here also end is the row alla. End is a column. End is a column. In bottom, end is a row. That means these are static. Start means it won't move. Start, end, end in the row, and here again what you have to do is something is decrementing. What is decrementing? Row is decrementing, but column is static. What is that column? That is 0. That is start. Perfect. Now what happens is cost plus equal to this end and this start. So uh, this is the end and this is the start. Start should keep incrementing. So what is that? That is nothing but J. Perfect, huh? Now next thing is bottom. It should be on the left. So dynamic one is column is decrementing, but what minus left? That is nothing but end minus J. Okay. Now start minus, yeah, something. Okay, J minus minus each time you shall do it. What is J equal to? uh, Start, then start minus minus. So instead of start is a number 0, and let's assume end is 3, 0 3 0 1 0 2 0 3. Then J is 0 0 0 3 1 3 2 3 3 3, right? Now 2 3, this one row should be decremented. No, column should be decremented. This should be 2, this should be 1, this should be 0. So സ്റ്റാർട്ടിലേക്ക് അത് പോകുന്നുണ്ട്. അതെങ്ങനെയാണ്? സ്റ്റാർട്ട് മൈനസ് സ്റ്റാർട്ട് ആവും. അപ്പോൾ എൻഡ് മൈനസ് ഷേ. ദാറ്റ്സ് ഓൾ. യാ ബ്രോ, 3 minus 0. I think so, but I am just cringing here. 3 minus 0, and so let's say, let me take a book and pen and paper. I don't understand this. So 3 3, start is 0, and end is 3 here. Start is 1, 3 minus 1, 3 minus 2, 3 minus 3. I think that is correct. So this is end is 3, right? 3 minus j. J will ultimately return to end. At that time, this happens. Now we have to go to the row. Row is what? It starts from end again. What is static? Start. No, no, no. Correct only. So this is 3 and 3. 3 minus 0 is 3. Uh, whatever be the number, you just add it. Put it. You just don't think about that. This one, j, and this one. All the four. What is the minimum value? You just add it. So now start j. I think that should be start, right? Then this should be start else. Uh, so this is 3 3 0 3 3 0, and this is no, this is start, right? First is start. This is 0 0 3 0 3 3 0 3. So 3 is end here. End is always static on the right. No, no. Yeah, row should be decrementing. So this is always the end. Let me think again. This is end. Row should be decrementing. That is, what is that row? That is j. So start is 0, end is 0, end 1 2 0 1 0 2 0 3. Right? Now next one is j. J is 0 3. No, no, no. End and j, right? So first one is end. Right? First one is end. This is j. Start and j, 1 2 3. Now end and j, 0. That is start, 1 2 3 4. No, 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 no. 3 0 and 0 3. Okay, I just made a mistake. So this is 0 and this is 3. Then j decrements the value. Now 3 3 comes. 3 should be row, and that is the end. This keeps on increasing. That is n minus j. Now we are coming from end. End is here and n minus j. What? No, yeah. So this one is n minus j. That is 3 minus 0. This one keeps going, and this one. So 0, right? It's a column. Column is static. So this is start. So one more doubt. Then if it follows a pattern, then this should be start minus j, right? This is end minus j. Yeah. First one is start and j. Start is 0 always. End keeps on incrementing the column. Second one is start and end. Start minus j. No, no, no. That is just j, because j and end. Yeah, correct. End and end minus j. Uh, Second minus j. 2 3. Okay. Uh, First you put end here. This keeps on decreasing. So that is n minus j. Wherever you want, you put n minus j. Decrementing n minus j. Okay. Then start, right? What is start? Start is 0 always. Yeah. I think this should work, or else we can just figure out what can be done. So we don't have to. I think this is not needed at all, or we'll just comment it. That's enough. So copy. We took too much time for this. It's ideal. It should not be the case. I think this should work. So before starting, cost is equal to 0. Cost, comma, result. So after all this is done, uh, cost equal to min of. So which one is smaller basically? So that's what I'm taking. And result plus equal to cost. Right. Uh, what we'll do? I think it's done. Let's see. I'm pretty sure it won't work, but if it works, it's a very big miracle. I would say. Awesome. Hmm. So string we should keep it as a character. Happened. Okay. Again, I think I messed up somewhere. CAT. This one. Oh, some error. Wow. J is equal to start. J is less than or equal to end. J plus plus. J does not name a type. I have no idea what I'm doing here. Start and end you declared everything is LL. Then what's the issue? Unqualified ID before for. J does not name a type. Expected unqualified ID before for. What did you expect? So let's remove this and check what's coming. Uh-huh. Wow. Oh, okay. So I think issue happened here. Right? What is this? That's okay. Warning, right? J equal to start, J less than or equal to end. What is happening, man? Oh, damn. I just. Shit. These things happen more than often, man. Wow. So we got some answer. Awesome. Did not initialize that 020596. That's close, but first one is Y2. It should be 1. I think if we could trace the first one, then it will be nice. 3. So, first one we took 5 and we took 3. So, we take this one string 010 010. Okay. I don't think this is here. There is no issue. I think the issue is with the algorithm. 0 less than 1. Okay. So if it should be less than or equal to n by 2, 5 by 2, 0, 1, you should take na. So 0, 1, less than 1, less than or equal to, it did not check. That's why it's taking that. I don't know. Yeah, it's probably that. Start is 0, end is 3 minus 0 minus 1, that is 2, 0, 1, 2. End is 2, yeah. 0 and 2, 1, 2. You take that, you take that, and you take that. Okay, cost plus equal to V of start. V of start is how much? V of 0. That is J is 0, 0. Okay. I think it's better if we print all this. Copy. We have time, I think I just need 20 minutes. Yeah, that's enough. Okay, I took the last number also, but that's not an issue, right? Uh, Last number, should it take or not? Okay, I'm actually calculating the cost twice if I take the last number. Second. Was that the issue here? No, it's just one. So I think one only added, right? So cost is why? It's all zero, right? Zero, 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 zero. Why did it add a cost? 4 minus 0 is 0, 0 less than this. What? So cost equal to 0 should be here. I don't think so. This would work. But I have nothing to lose. 1, 0, 11, 11, 9. God. Oh my god. Nice. I got screwed, man. But I have to see whether my intention is correct or not. Let me see that. Let me work out. 0 0 1 0. This is insane. I have no idea what I'm doing. So this is 4 and 0 0 1 0. So plus 1 0 1 1 1 1 plus 1. I think my intention is right. Something is going wrong. Let me just debug this. Triple 1 0. So 1 1 1 0. Correct. So that cost is 1. 1 0 1 0. No, that's not. It's not 1 0 1 1. It's 1 0 1 0. Yeah. So what happened here is this is wrong. Last one. That is end minus j and start. Start is what? Last is not start, man. This is that is start only. Yeah, that is at 0. Oh, 1 2 3 4. It's in the middle. So 1 1 1 0 1 0 1 1. Correct. 0 the 0. This one 1 1. Correct. 0 0 1 0. Correct. That's it. 0 0 1 0. Outer layer is covered. Now let's go to the inner layer. Okay, so inner layer there is a problem. I say that start equal to I, right? I is what? 1. Uh, start 1101. What is 1101? Yeah, 1101. It took the last also. Uh, we are the first one will not only be there, right? So I think the last is not needed, right? So how do you handle that? I less than last. Yeah, I think last is not needed. 7. Oh, we are so close. 0 0 1 0. Now next one is 0 0 1 1 0 0 1 0. Yeah, it's not 1. Uh, 2 noob to be here, man. Start and end is 3. 0 1 2 Oh, okay. So this is minus I minus 1 minus I minus. Yeah, correct only, no. So that is 0 and 4, then 1 and 3. Correct. So 1 and 3, you take this one here. Oh, you're starting from top again. No, I'm starting from this only. Yeah. There are only two checks, right? This is a small three rectangle, 1 and 2. 0, 0, 1, 0. So how did this happen? Uh, what is end minus j? End is nothing but 3, right? 3, 0. Uh, end minus j is 3. Yeah, you are in the row. And start is what? 1, 3, 1. 3, 1 is obviously 0. 0, 0, 1, 0 is okay. Now 0, 0, 1, 1, 0, 0, 1, 1. What? 0, 0, 1, 1. 0. See out start, see out J. I think I should do everything. I am close, I think, but I'm not sure. Like, anyway, start J. I'm getting trimmed, but no problem. Let's try to solve this. Uh, I don't know what's wrong here again. So, if you see, right, let me make myself smaller. This is too big. Yeah, this is perfect. Okay, so 0010, right? That is 0010, correct? Start is 1, end is 3, 1, and this is 3. Uh, start is 1, end is 3, J is 1, okay. End minus J is 2, correct, okay. Start and J, is it like 1 and 1? It should be 1, 1, correct, 0. Then next comes 1 and end, J and end, J end 1, 3, 0, 1, 1, 1, 2, 3. Yeah, correct. Next comes end and n minus j, that is 3 and 2. Correct. Okay. 0, 1, 2, 3, 0, 1, 2. Okay. How did 2 come here? It should be j, right? Okay. So the mistake is this one, 0, 1. So that is the highest number. What it did is, what is that number, first of all? 2, right? 2 is what? 2 is j's value, that is n minus j, right? That is n minus j. Exactly, right? That is n minus, I'm not sure. Uh, It's not end minus j, it's just end, that's all. Yeah. Okay, let's say 0, 1, 2, 3. Then what is this? This is, if this is 3, 0, 1, 2, 3. 3, 3. It should be 3, 3. I don't know what is 3, 3. Uh, ah, Start and j, j and end is okay. Then end minus j start. End minus j, that is, end minus j is 2, 0, 1, 2. Again, it's wrong. Start is correct. Everywhere start is correct. The thing that is moving is, yeah, start I'm handling it properly, but end I'm not handling it properly. This is what? This is total number minus I minus 1. That's it. That is n. That's all. Okay, let's maybe try the next iteration. That is this one. Start plus 1 is what? 1. Start is 1 always. Yeah. Then this is j plus 1. Correct. Okay, that is 2. Correct. Now it goes to uh, start. No, no. Uh, what is happening? J and end. J is start plus 1. Correct. And end is what? Uh, End could be. This is. Yeah, end is also correct. That is 2. So 0, 1, 2, 3, right? Why it came as this? Huh. End is 3. Yeah, end is 3, correct. Now, end minus j and start. Start is 2, correct? N minus j. So that is from bottom I should take. So end is what? End is 3. 3 minus j is. I don't know why it's not 1. Why? 2, 3, 1. 1, 2, 3, 1. End is what? 3. 3 minus end, that is total end, that is total end minus j. Total end minus j. Will that work? Is j. Total end is, or you just put end, that's enough. No, end if I put means, what is the, yeah, that thing I should know, right? N minus I minus 1. I am putting here now. Total end, that is 3. 3 minus end, right? Shit. 4. 4 minus 3 is 1. Uh, that is minus j. What? Either plus in end minus j, that's all. What is end? End is 4. 4 minus j, that's all. And I don't know why I'm doing n minus I minus 1 here. End is obviously 4, right? End is n minus 1. It's 7, man. What is happening? I'm not sure like that, but 1, 3, 4. So it is something like hmm, hmm. What is 1? 1 is n minus j is 1. So no, no, no. This is 0, 1, 2, 3. End minus I 1. Total end minus I. That's all. Right? Total end minus I. So this is static? No. Yeah, this is static only. That is end. That's all. What is changing here? So we take this one, then we took this, and column wise it's changing. Last row is static. Row is static. What is that row? That row is called as 4. No, end is 3. 0, 1, 2, 3. Yeah, row is correct. What did change? It is not end minus j. It is uh, this is total end, I think. Right? 3 minus total end minus j. Wait. My card. Got n minus I minus 1. That is static. No. So end is static, but right side how the column decrements, it's a problem. So let's try like J should not be start. J should be I. Yeah, that is only. God. Increment minus J. Nah, decrement minus J. What is it coming? End is what? 3, right? 1, 2, 3. End is 3. 0, 1, 2, 3. End is 3, but this one is J only. That is. What is it coming? Let's say. What is end minus J is 2? 0, 1, 2. That's correct. 0, 1, 1, 1. Yeah, what's wrong? I don't know. I have no idea, man. 0, 0, 1, 0. Okay. So start is 1, correct? J is also 1. J is also 2. 1, 2. Because end is what? N minus I minus 1. N minus I minus 1 is what? Uh, 4 minus 1, that is 3. 3 minus 1 is 2. 2. End is 0, 1, 2. No. End should be 3. Now end should be 0, 1, 2, 3, 4, 5. 5 minus 1 minus I. Yeah, so this one. End is 4 only, right? Yeah, end how it became 3. Because start is there, end is 3. What? I equal to 0, I equal to 1. 0, 4, 1, 3. 0, 4, 1, 3. 0, 1, 2, 3. End is 3. Okay. So first one is it took 0. Start and j, that is 0 and 1. Correct. Now next one is j and end, that is this one. J stands for 0 and end is how much? 3. 1, 2, 3. Okay. Now end and end minus 0, 1, 2, 3. End is 3. End minus j, that is. Okay, wait, it's not that. How is it deriving? That is column. Column means end. Let's do one thing. It's done. Yeah. Oh my god, what is this? Shit. Hey man, insane. Oh my god, thank god. I'm back. Accepted. I think it's just 10 minutes, but let's read the question. So I think you have already solved like 5,000 and yeah man, I need more practice. 5374. You're given an array, count the number of pairs of indices such that AI is less than I less than AJ less than J. Sum of n over all test cases does not exceed 2 into 10 power 5. For each test case, output is single integer. The number of pairs of indices satisfying the condition in the statement. Please note that the answer for some test cases won't fit into 32-bit integer type. Okay. So you are given an array that is this. Count the number of pair of indices such that ai less than I less than aj less than j. Uh, so you are telling like one less than one. What is this? For the first test case, the pairs are 2, 4, 2, 8, and 3, 8. 10 power 5. The pair 2, 4 is true because a2 equal to 1, 0, 1, 2, a2 equal to 1, a4 equal to 3, So a 1 less than its index less than 3 less than its index. Oh, okay. Nice. But how do I solve this? 2 and 8. No, what is the pair called? Index pair. Okay. We definitely can't brute force this because obviously it's 10 power 5 and it's a E problem. Yet another problem about pairs, satisfying and inequality. Okay, we'll just think about it. So, um, so what to do here is I'm not sure. I'm not in a mood to do also. Let's see. Uh, I don't know. Not like don't know. We have to spend some time. If the number is, if the index is there and if the number is also there, find all the numbers that are on the right side, which is having the same inequality, right? 3 less than 4, so that is a valid. So take all the valid numbers. So let's say 3 is less than 4 and 8 might also be less, right? That is 1, 3, 2, and 4. So 3 is a number, that is 4. 3 less than 4. So this one you should take 1 less than 2. Whatever numbers are valid, you put everything in a, keep on putting in a queue, priority queue. So 1 less than 2 is there. How many numbers you could match such that all those numbers are there? But this number should be greater than this number. So how do you do that? You put all the numbers in a, this one, put the number, find the lower bound, take those set into that. Take this one, check the numbers, uh, take the second number, do a binary search. See, binary search idea came because it's 10 per 5, so it's like n log n type. I think I can do it, but unfortunately, I'm closing the contest. So let's see the standings. Like, what is our rank? Uh, we did well. So E is good. We did well, yeah. So we have a think like 5,659. 5,659. So I don't know. He is like plus 29 for it. 1,159. Wow. My God. Nice. Okay. So what I'll do is everything is clear. F could have been solved, but I'm not sure like whether it's done. So I'm closing the contest. We have solved like 5 problems, and main important thing is it's not due 2 or due 3, it's due 4. So obviously the problems are simple here. The thing is it's more like implementation wise it was hard, so it's good to practice it. See you guys in next stream. Thank you.